Okay, so in this problem, we're being asked to analyze somebody who's throwing a discus. The tangential and radial components are also what we're being asked to analyze. A discus thrower turns with an angular acceleration of 50 radians per second squared, and he moves the discus in a circle of radius 0.80 meters. We're being asked to find the radial and tangential components of the acceleration of the discus and the magnitude of its acceleration at the instant when the angular velocity is 10 radians per second. So this question here has two parts, and in part A we're being asked to find the radial and the tangential components of the acceleration of the discus. So to find both of these, we have a formula. So we have to find the tangential component, we just have to multiply the radius times the angular acceleration. So we have both of these values, so we know that the radius is 0.80 meters, and we know that the angular acceleration is 50 radians per second squared. So we just multiply both of these values, and it gives us 40 meters per second squared. So that's the tangential component. And then to find the radial component, we have another equation, and then here we have the angular velocity squared times the radius. So we have both of these values. Once again, we know that the angular velocity is 10, and then we square that and we multiply it by the radius at 0.8 meters, and that gives us 80 meters per second squared. And now for part B, we're being asked to find the magnitude of the acceleration. So we already have the two components, the tangential and the radial components. So now we would just need the acceleration here, and to find the magnitude, we need this equation. We use the radial component and we square it. We would take the radial component squared, and then we would add it by the tangential component squared. And we already know that we got for the radial component we got 80, so we would square that. And then for the tangential component we got 40, so we would square that as well. And then when you just square root both of these values, the answer is 89 meters per second squared. And that's the magnitude of the acceleration at the instant when the angular velocity is 10 radians per second.